So we know that we need to be engaging learners in the practices of generating and refining knowledge. So the next generation science standards, which is based on a science framework or a framework for K-12 science education here in the States, outlines these practices as 8 science practices. And the way that we've been thinking about this in my group is that if students are going to go forth and have these science practices in their toolbox for sense making, then what they really need is what Alena Moon calls a deep understanding of them. They need to understand the epistemic foundations for science practice, which is really one simple question: what makes scientific knowledge good? And to think about this, my group has sort of zoomed in on this central box that if we want to start figuring out how students think about what makes a scientific knowledge product good or not so good, we have to look at this evaluation piece. And I came from the Schultz group. That's where I did my postdoc, where they do lots and lots and lots of writing. And Ginger Schultz planted this peer review bug inside of me. And so when I started my independent career, I thought, hold up, peer review is a tool here. Peer review is a way that we can start exploring how students do this kind of evaluation work. And so in my independent career, this has been our big question. What's going on with peer review? How do students do this kind of evaluative work? And when we very first started, one of the questions that I would repeatedly receive in reviews and discussions was, can students even do peer review of knowledge products? As I've progressed, I've realized that this question is a teensy bit problematic because it's like really inherently deficity, but I'm going to still address it. In order to address this question, one of my graduate students was doing a study where she was looking at how students play with data to make claims about an optimization process. In this specific data set, we were looking at how to extract metals from waste technology. And you wanted to sort of extract desired metals and minimize extraction of waste metals. And so we thought, let's use this as an opportunity. And what Stephanie did was she pre-constructed responses that included epistemic weaknesses, which means, for example, one of them like only considered one variable, right? And we thought, let's, after students construct their responses in these interviews, let's have them evaluate these pre-constructed ones. We'll tell them it's from their peers and see if they can identify the epistemic weaknesses. And we did it. We weren't really expecting it. We didn't know what to expect, I guess I should say. And what this study gave us was a really resounding yes as an answer to this question, which is students are very, very competent at identifying salient features of another student's response, right? So they were able to distinguish what made those responses unique. Okay. But then we had some students who took it even a step further. So take a second with one of my favorite participants ever. So Bruce did something kind of amazing here. What's significant here is that he reviewed this pre-constructed response that had selected the same answer that he chose in his, and still read this alternative response and concluded that he had not actually used evidence to support his claim, which is like the critical sort of epistemic criterion for engaging an argument of this kind. Okay, so we think we have a bit of an explanation for what's going on here. which uses what we call social comparison theory. And this is like an oldie in psychology, but really, really useful for thinking about peer review. What happens is we have this learner in the middle, and learner, human, everyone does this. When you are placed in a situation where you're feeling uncertain about how to act, what to do, what to think, one way that you can resolve that uncertainty is to make comparisons to other folks and to extract criteria for what is expected in that domain. And there's all sorts of comparisons you can make. You can compare to a similar other that seems really competent. You can compare to an authoritative presence. You can compare to someone else that feels confused, right? And what you do is you extract criteria from all of these comparisons to figure out what you may need to do in that specific domain, and you feel just a little less uncertain about it. And so what we did was we took these interviews that we'd done, and Stephanie constructed a model using social comparison theory that outlines these different pathways for making these comparisons and extracting information from them. And on the left, you can see these pathways where learners are sort of can feel real confident as they're going through these comparisons and don't really use them to extract information. Or maybe they're just not engaging in the tasks in that way. On the right-hand side, you can see these paths where students are identifying gaps and weaknesses in their own thinking, and either making changes to smaller bits based on the information they're extracting, or even completely adopting these targets that they compared to. And this is helpful, right? We can explain what the different approaches may look like, but we were still kind of stuck with, well, why are there these different approaches? Why can two students walk into these social comparisons and walk out real different? And so I'm going to show you a model that we are proposing to explain why we see these differential pathways. Okay, I don't have a cute name for this yet, but here's what we think is happening. We think that students are extracting these criteria through making social comparisons and through receiving feedback and learning in class and all the things that they could participate in. And my proposal is that what may be influencing how they navigate this is their epistemic cognition, which is how the learner views themselves as a knower and acts on it. And this is particularly relevant because we are engaging them in the science practices, right? So my big guiding question here is to try and sort of illustrate what this could look like to you by exploring the question of how students' epistemic cognition shapes their engagement in peer review. In order to think about epistemic cognition, we use a model from Chin called the AIR model. I don't know that it's the strongest name, but it is a great model. So in this model, we think about epistemic cognition as being comprised of three different domains. One's epistemic aims and values. So what's the purpose of the knowledge building that you're doing? Epistemic ideals, which is what are the qualities of that knowledge that you're going to be building? And then reliable processes, which are how do you achieve the construction of knowledge that you're targeting with the qualities that you've identified as important. Okay, so this is what we're going to think about to characterize what students are doing. Okay, let me tell you a little bit about how we collect data. The first really critical feature of collecting data to answer these questions is having very, very creative graduate students. And I have one graduate student who has designed this task where some really interesting intramolecular forces give rise to a conformation that just contradicts what students expect. And so with all of our tasks, we pull problems, data from the literature. And our goal is to have something that requires sense making. In this case, it was an observation that countered what they would expect based on what they learned in class. Then, in this specific context, we were very inspired by an older Talon Care paper called When Atoms Want, where he explored what students sort of desire in an explanation. And in order to, I guess, follow up on this inspiration, we crowdsourced explanations for this phenomenon from everyone we had access to, which meant undergrads in our group who were taking organic, undergrads who had never taken organic, graduate students who were studying physical chemistry and who didn't think about organic, and then some real organic interested graduate students. And in crowdsourcing these explanations, they ended up taking forms that kind of mapped on to other work by Sevian and Talon Care on modes of reasoning. And what we found was that we had some pre-constructed responses that were really, really descriptive, which means they just relied on delta G. They just said what it was and then used that as a causal explanation. We had one constructed response. This was constructed by the person who designed the task that we would think of as a causal mechanistic response. It uses both attractive and repulsive forces to explain an outcome. And then we had two what we would call relational responses that linked sort of common causes in organic, in one case bulkiness, in one case repulsive forces, to an outcome. The only issue here is that those causes didn't really explain the outcome, but what they gave us insight into is how students identified them as favorable or not. So these were the pre-constructed responses. The task that was actually given to students required them to identify the explanation that they thought best explained the phenomenon, and then justify their elimination of the other explanations. This is what was actually submitted online as part of their assignment, excuse me, and what was subjected to peer review. So what happens is students submit this online, it goes through peer review. In this way, the whole domain of peer review is like inherently epistemic because they are literally evaluating out loud, well, electronically out loud, what they think makes a good explanation and what doesn't make a good explanation, and then critiquing each other's evaluation of that. Then students have an opportunity to submit a second draft if they want to modify or anything about the reasoning. They have some opportunity to give feedback about how peer review impacted their thinking. And then often we bring students in to interview afterwards. And this is like a response process interview where we just go through the entire activity and they explain out loud how they were engaging in the activity. And this gives us lots and lots of insight into sort of their individual approaches and justification for how they were reasoning. And so this interview data is what I'm going to show you. I'm going to try my best to illustrate how learners' differential epistemic cognition may have been impacting differential ways of engaging through two contrasting cases. We're going to focus in today on strawberry and banana. And strawberry and banana chose the two different responses that we would characterize as relational, right? And the interesting thing is that they both started with sort of the same goals here. Both wanted to get the right answer, and both were sort of motivated to find something that made sense to them. Strawberry illustrates this for us, where thinking about bulkiness made sense to her. And then banana says, I just really needed to figure out what was right and what wasn't. All right. So same starting point. Now we're going to walk you through Strawberry's path. In the very first peer review that Strawberry does, they review someone with the same answer. And they're kind of struck by the fact that they focused on different things to select the same answer. And when prompted to articulate how this evaluation affected their own thinking, maybe this is like a nod to epistemic affect, they felt a little shaken by the fact that there could be two different reasonings or justifications for the same answer. And what this did was it focused them in on the why, that there was like this critical piece of justification. And so we see them activating this epistemic ideal. They then go on to review what counts as a really descriptive explanation. And we see them digging in on this why piece. So why is really, really critical here. And the reliable process that motivates for Strawberry is to spend a little bit more time, that they recognize that there's need for a lot more thought here if they're going to be able to offer the kind of justification that they're realizing is really important. So then Strawberry reviews an example that's very causal mechanistic. So we see quite a few of what I think are kind of amazing things emerging here. Strawberry's super impressed by drawing on multiple reasons to justify an outcome. So much so that it made B a much more compelling answer. And it made Strawberry think that C was not as compelling because they had singly relied on one variable. And so we see them motivated to consider multiple reasons, negotiate multiple reasons, and again, really dig in and spend a lot more time here to accomplish what they're trying to accomplish. So after they've done all this review, we ask them, how are you thinking about your answer? And this is what Strawberry says. And so again, we see this really beautiful activation of this aim of justifying, that this is all going to rest on how effectively they justify their reasoning. And in practice, what this motivated was Strawberry submitted a revision, switched from C, this relational reasoning, to B, this causal mechanistic reasoning. And in their justification for their switch, they specifically use epistemic ideals for explaining why. And even more impressively, they went back through all the images and they identified all the critical changes between images. And these were images of the reactions with corresponding delta Gs, and said that my explanation needs to account for every single one of these differences, right? Okay, so I think that this is what Strawberry gave you is how someone can activate this really beautiful epistemic cognition that can shape really meaningful participation in these practices. Okay, let's contrast this a little bit with what Banana did, who started with sort of the same ideas. Their first peer review involved reviewing someone with a different answer than them. So we see the same motivation of trying to get the right answer, but then what that does is raise something a little suspect, maybe, where Banana sort of questions the authority of their peers and whether or not they can even trust what they're doing. They said in other parts of the interview, like, who knows if they just put this answer in willy-nilly and can I even trust it? In contrast, if it was a TA, they could just drop everything and believe what they were saying. That's 100% true. So, okay. They then go on to review one of those really descriptive explanations.
I just called 2 minutes there, Alena.
I added stuff in the second before this because I was worried about time. I'm a mess. Okay, I'm sorry. So yeah, I'm gonna be a little bit speedy. Here we see the same idea that they really trust TAs, but they're not really trusting their peers. They review another C, so now at this point, 2 out of the 3 folks they reviewed had the same answer. And here we see this epistemic ideal of using sciencey words, which is fine. We've seen that before. And we see this really promising epistemic reliable process of maybe leveraging consensus to inform their thinking. But it doesn't inform it enough. So wait and see what actually informs their thinking. This is why these interviews are so amazing, because we got surprise information. So earlier in the interview, Banana had expressed pretty active discontent for the option C, but talked to one of their friends who's like a definite smarty and probably knows, and ends up switching their response to C, but doesn't really justify. So when we compare and contrast these two cases, we see that we see an example of sort of how these really sophisticated ideas can develop. And we see this contrasting example of how certain epistemic ideas can really narrow the engagement. And I think that this motivates us to consider some things. I think in order for peer review and engaging in science practices to be useful for supporting deep understanding or this epistemic foundation, there's a few things we have to like curb a little bit. One is this like all-consuming focus on the correct answer, and that perceived authorities are the singular determinant of the correct answer, in contrast to, say, evidence. And then I think that we also need to, and this happens over a really long time through setting norms, support some other ideas, which is that students have authority to evaluate each other, right? Like that's what we're doing. Okay. This is my adorable group. They chose turtlenecks as our group photo, and I can't get over it. And then I have one more acknowledgement. And because I don't know if you all know, but I did my PhD with Marcy Towns, and she's a queen. And she taught me like all sorts of magical things about how to do research and how to be independent, how to ask good questions and creatively think about solving them. But then I wanted to show you one picture that I think illustrates things that she taught me that are way more than that. I had to dig really, really deep. But this is Marcy's son with my soulmate, Layla. And the reason that I show you this picture is because Marcy like made you feel like you were a part of her family. And she still makes you feel that way even after you've left her group. And that is absolutely not trivial and has played a significant role in my professional development. So that's my last chunk. Oh, well, all right. I'm gonna stop sharing.